All right, welcome to the last video on solving circuits, and this is solving complex circuits. And that sounds a little scary, but it's actually not too bad. These questions aren't necessarily harder, they're just a little bit longer. And so complex circuits look like this. We've got really two parts to it. We could have more, but we're keeping it to two different parts. We've got a part here, and we've got a part here, okay? And so we are going to learn how to solve circuits like this, where we've got these different sections, okay? And so when we get one like this, one of the first things that I think you should do is think about, okay, what are these different parts? What do they look like, and what's the electricity? What are the electrons doing as they go through here? Well, the first section here, these two are parallel to each other. So 1 and 2 actually go together, and so we've got a bit of information here: 18 volts across resistor 2, and 2 amps going through resistor 1. But I think it's helpful to just block those two off. So these two go together, right? This column and this column go together. So draw a squiggly line like that and separate it off. Okay? And then at this point, remind yourself of the rules. What are the rules for these? Well, these are parallel. And so with parallel resistors, the voltages are equal. And what about current? Well, the current through parallel sections, parallel resistors, these add up to the total current. Okay? So you really want to make sure that you know those rules. Okay? So voltage drops across parallel resistors are equal. So these two drops, okay, remember this is a voltage rise. Losing voltage across a resistor, we call those voltage drops. Okay, and so these are going to be equal. And the current in parallel pathways, these are going to add up to the total current. Okay, so if that's true, then this one is also going to be 18 volts. Okay, because they have to be equal. All right, what about I2? Well, these have to add up to the total. So I can just go like this, I total minus this one, that will give me I2. Okay, what is the total current? Well, all of the electrons, all of the current is coming through the ammeter here, and that reads 6 amps. So the total current is 6 amps minus 2 amps. That gives us 4 amps. Okay, so there's 4 amps coming through this. 2 amps coming through resistor 1, and 4 amps coming through this one. Okay, let's figure out resistance. So we'll get to this over here in a bit, but let's first do resistance. How do we find resistance? Same as normal. The only way to find resistance is with Ohm's law, right? R is equal to V over I. Okay, R1 equals V1 over I1, and we have those numbers: 18 volts over 2 amps. That equals 9 ohms. Same thing for resistor 2. R2 equals V2 over I2, 18 volts over 4 amps, and that gives 4.5 ohms. Okay, so this, hopefully that seems familiar. That should be like the last video where we were dealing with parallel circuits. Okay, what about this thing now? Okay, this column is from this resistor. Well, again, it's very helpful to think about any individual electron. So this electron, how many resistors is it going through? Right? It's starting with, we can say 24 volts. That's a bit simplistic, but that works for our purposes. Okay, it's starting with 24 volts, and it goes through the circuit. Okay, so let's say it goes this way. Okay, and then it'll go here and back to the battery. So it's lost all 24 volts. Okay, so it had 24, went this way, lost some voltage there. How much did it lose? Well, it lost 18 volts across resistor 1, and then went this way and lost the rest there. Okay, it loses a tiny bit in the wires, but for the most part it's losing it in the resistors. So if it started with 24 and lost 18, how much will it have lost here? Well, we can take the total and subtract either V1 or V2. Doesn't matter, just one of these. Okay, because another electron might have started 24 and gone this way and lost 18 and then went through there. Okay, so total voltage 24 volts and we subtract 18, and so it lost 6 volts here. Okay, good way to check is you can take any voltage on the right side of your squiggly line and one of the voltages on the left side of your squiggly line, and they should add up to the total, right? 18 and 6. Okay, current. How much current is going through here? Well, 6 amps is coming through here, and then it splits up. It's 2 amps here and 4 amps here, but then all of the current comes through here, so that is 6 amps there. Okay, because all of the current's coming through that resistor. And what about R3? Well, again, the only way to find resistance is by using Ohm's law. R equals V over I, V3 over I3, and so this is 6 volts over 6 amps, 1 ohm. So I hope that makes sense. They're not easy, they're complicated, but it really helps to divide it up by putting your squiggly line in place, and then by just solving one section at a time. So please try the practice problems, and I think that will really help.